With buildings accounting for nearly 40% of greenhouse gas emissions, architects are on the forefront in the fight against climate change. Every new project is an opportunity to reduce emissions and develop a more sustainable and resilient built environment. In this video, we are going to discuss what embodied carbon is and how you can reduce it on your building project. My name is Nathan Griffith, and I am an associate principal here at Neumann Monson Architects. At Neumann Monson, we are committed to a more sustainable future. We have joined the AIA's 2030 commitment, an initiative that calls for all new buildings, developments, and renovations to be carbon neutral by 2030. One of our goals is to reduce embodied carbon by developing innovative solutions and educating our clients on the best practices. This video will explain embodied carbon and discuss the most effective strategies for reducing these emissions. Embodied carbon is the total greenhouse gas emissions released during the life cycle of a material, product, or system. It is calculated by tracking the emissions associated with each phase of a material's life cycle, including raw material extraction, transportation, manufacturing, construction, maintenance, and disposal. Of the 40% of greenhouse gas emissions released by the built environment, 13% are related to materials and construction. Embodied carbon is one of the biggest challenges for the building industry. While we can work to improve a building's performance and reduce operational carbon emissions, embodied carbon cannot be taken back. As the prime specifiers of materials and systems, we can educate building owners and promote low-emitting options. Reusing an existing structure is the most effective way to reduce embodied carbon. This practice decreases the demand for new building materials and the carbon emissions associated with demolition. According to the Environmental Protection Agency, it can take 65 years for an energy-efficient building to save the energy lost in demolishing an existing one. In many cases, an existing building can be repurposed to fit a new use, a practice called adaptive reuse. Renovations and adaptive reuse should include rigorous waste management strategies. Recycling materials and reusing existing elements help reduce embodied carbon and costs. Your architect should work to maintain the largest systems and material masses to minimize replacements. Reusing an existing building can present challenges, but an architect can help with the site selection process and evaluate the feasibility of different options. Efficient space planning can also help reduce embodied carbon. To minimize materials, architects should be rigorous in their approach and make efficient use of space. Efficiency also extends to interior finishes, and designers should work to remove unnecessary elements and develop a minimal palette. Planning a degree of flexibility can help reduce future embodied carbon emissions. A building's use will likely change over time, so it helps to anticipate future modifications. A flexible layout helps a building maintain its use as occupants' needs change, reducing the likelihood of demolition. Reducing embodied carbon requires research into building materials, systems, and their associated emissions. Programs like Tally Carbon Calculator provide product data and help designers compare options. Thousands of materials go into every building, so it helps to focus on the areas of the greatest impact, like structural systems. A concrete structural system has high levels of embodied carbon due to its energy-intensive production process. Steel has slightly lower embodied carbon levels, though it's still less than ideal. Systems made from sustainably harvested wood have the lowest embodied carbon levels. Wood sequesters carbon within the building, making structural systems like mass timber the most sustainable choice. Exterior cladding is another area where embodied carbon research can make a significant impact. Although larger building assemblies like cladding have the greatest impact, this type of research can occur at all levels of the project, including interior finishes. Reusing an existing structure is the most effective way to reduce embodied carbon emissions. Adaptive reuse projects provide the opportunity to prevent demolition, minimize waste, and reuse materials. At the same time, they offer the opportunity to preserve historic buildings and revitalize communities. Often, these projects present financial incentives, like tax credits. Learn more by clicking the link below to read about financial incentives for adaptive reuse in Iowa. Thanks for watching.